So I guess we are live. Let's edit the title. stm32 porting guide. Yeah, part 2. That's it. Save. And I guess we are live. So in the previous stream, and this stream won't be too longer, and in the previous stream I tried to connect my board to the Q ground control, which is the UI to set up uh, all the configurations using um, on the board. Sorry, let me set up the board. Yeah, so the thing is, I tried couple of things to boot the board, but the problem was I didn't have an SD card on the board at the moment. The problem is Px4 by default uses SD card to save all the configurations, but yeah, so let's see where are we. So to get things clear, the development environment for Px4 is you need to have Px4 firmware, then the kconfig tools, and the Px4 bootloader. There is a bootloader for Px4, and by default F7 comes with its own bootloader, and you can activate that bootloader by holding down the boot pin, and using reset pin to reset the board while you are holding the boot pin, and then you can activate the DFU bootloader, and you can load the code using that, and you don't need stling for that. But the main problem is that debugging will be too much harder for us, because since there is no stling attached to the stm32. Now let's move on to the main thing. What I have done so far is, if you can see, yeah, so the problem is waiting for vehicle connection. Okay, so what I have done is just activate my development environment, then upload this Swift FC board firmware and let it compile, and my machine is going to blast since I am streaming and compiling both together. Let's see how it goes. So the main thing is, with NutX, while it's compiling, let's talk about NutX. So if you code, I have heard lots of people are saying that if you code on NutX, there is some portability which is the advantage of the NutX. If you are coding on the Linux and you have coded something like you want some read write operations, you have done something with I2C with UART on the Linux, then the code will be the same. Yeah, you need to compile it from using the ARM GCC, since on the Linux you are using the GNU GCC, and then you have to move on to the ARM GCC. So you have to recompile the code with ARM GCC, but the code base will be the same, since you have wrote so many codes about the
communication lost,
IP
manual flight
and
mode,
other
communication
things.
regained, communication lost.
Yeah, I understand that. I understand you have lost the communication. Let's reset the board. Now it's erasing the flash and will be. So this is a Px4 bootloader, and it's flashing the Px4 firmware. Now it doesn't need stling for that, so you can detach the stling. And the main advantage of Px4 bootloader is you can load Arduino Pilot as well.
Communication regained.
So this is the thing. Now we have regained the communication, but the main thing is
pre-flight fail, compass sensor 0 missing.
Yeah, I understand. So lots of things are broken at the moment. I have just successfully added connected the ground control to the board, so that's the new success. but the main problem is that whenever I apply anything, any settings on the Q ground control, it doesn't apply on the board, since it is hard coded that it will use uh, SD card to store configurations. But I'm trying to do one more thing, is that the all the configurations, all the oops okay, all the configurations will be saved on the internal flash, and all the logging. So the main purpose people are using micro SD card is for logging, and since this is the just a development board, I don't need the logging, so I'm going to skip that part and move on to just internal flash for configurations. And let me let me show you how it can be done. So yeah, so it's loading. So that is this called RCS file, so I have renamed it and I'm using RCS, and now I changed the parameter. So all the files are over here. This is the param file. So in the nuntext you will find some directories similar to the Linux, and it's called the etc params. Previously it known as the fs micro sd. Now how it will came to fs is that it tried to mount sd card as the fs micro sd card, then those things will be used as the params. So that's how they keep configuration after you upgrade your firmware. So that's the good one. That's why we need to use the SD card. But since I don't have this on the development board, maybe we can skip that part. What we can do other part is that we can definitely try micro SD card Arduino adapter. We can definitely use some kind of this adapter. Let me see. In India there is like very few websites to sell very cheaply. So this is the stm32f765. okay, so this is an SPI connection. Now we need to look at STM32 SDMMC connections. As long as we have SDMMC connections, it will be pretty easy for us to connect. Okay, so there is been an image. Oh, it's too small. Yeah, so that's not here. So it says ST serial, then SCLK. Okay, there's another one, SDMMC. So it's like it's an SPI connections, but let's see on the STM32Cube IDE. And I have already posted all the things on the discussion forum. Let's see how it goes. So my streaming is working perfectly. So now it's open. Let's check out that as well. So let's go into this one. So I guess we are good to go. So if I remove where is my KiKid project? So what can I do to testing? If I do have one SPI connector exposed, so I will make sure next time I will expose all the pins on the board, so I can easily use those pins to do development task. So what can I do is, other thing is that I can use this SPI bus which is connected to my MS56 barometer. So I can remove the barometer and then directly use the SD card and do some development stuff using that module. Let's see if that can work on this part, SDMMC. So there are two SDMMC. So first one I cannot use since I guess it uses okay, conflict with, okay, so it conflicts with I2C and all the okay, so there is too much. Now let's see SDMMC2. So okay, so SDMMC 4-bit wide bus it can do. Okay, so what are the GPIOs for that? Okay, so there, those GPIOs are on the top. Basically 1 2 3 4 5 6 1 2 3 4 other GPIOs are somewhere else. Okay, so here are they. Okay, so maybe I need to update those things. And what about 4-bit bus? Okay, so 4-bit bus I can use this, and it will not be a good to use 1-bit bus because since it's not a good idea. Okay, disable, let's disable it. And SDMMC pinouts. Okay, so it is different than SPI. So it's not like a normal SPI where we can directly connect where my MS5611 is connected. I need to figure out that thing. So this was an update part, and now I'm going to try hook up SD card on the board, and let's Px4 take over to the other parts. That's a cool board. Other than that, I have found that there is another chip which is very useful since it doesn't have LCD controller, and maybe it will be cheap for to me by stm32f765. Yeah, so this one chip is also available in the market. It does have very small flash than the current chip since it is 250 KB flash, but I need to attach another external flash for this chip. So maybe we should skip the idea and stick to the stm32f765 since it's a costly chip, and maybe I was finding some other chips for that purpose, but it may not work. And let's see the 3D diagram. I haven't changed anything yet. I'm planning to put the MPU 6050 on the board, but since MPU 6050 is also deprecated, there are other sensors which can be used, like the Px4 supported hardware. Let's see that. Most of them are Chinese manufacturers. So yeah, so this one, so I'm following the guidelines for Px4 as much as possible to make this board available very quickly. Okay, so this one got here the SD card. If you can see, there is a minor slot over there, and these are the barometer which it the IMUs which it uses for that purpose. The main problem is that this barometer doesn't have the breakout board, so I have to build one myself, which will be very costly since it's in prototype, and prototype doesn't